Here about is a future activity, so a program running in fall this year, so next semester, and it's on blockchains and where else that sort of technology can be applied, associated problems, and the main organizer for that program is Chiesa, and Ale.
Hi everybody. So this program is co-organized with Eli Ben-Sasson, Yael Kalai, Rafael Paz, and Mike Wallfish. So the official title is Proofs, Consensus, and Decentralizing to Society, though I guess between friends we can call it the blockchain program. So actually the title is informative in the sense that it directly relates to 3 scientific themes that we'll be thinking about during the program. So we can think about them as pillars. One of them is cryptographic proofs. The other one is large-scale consensus. And the last one is the use of these tools to deriving applications for decentralizing society. Now these 3 scientific themes actually cover a rather broad range of topics in computer science and beyond, all the way from complexity theory, cryptography, and programming languages to distributed algorithms, game theory, and also beyond computer science, questions in economics, law, and ethics. So let me tell you just a little about some of these themes. The first one has to do with proof systems. This is a beautiful theory that we've developed in computer science over the past 3 decades, and it's a really powerful lens to solve many problems in complexity theory. But perhaps one of the most compelling use cases of proof systems is a very direct one, where if you have 2 parties, Alice and Bob, and Alice wishes to convince Bob of a computational statement, then the 2 of them can engage in a proof protocol, where Alice plays the role of the prover and Bob that of the verifier. And besides sort of achieving the properties of a proof system, we know today of how to achieve some pretty amazing properties. One of them is that of delegation of computation, where where Bob can actually check a computation exponentially faster than it takes to conduct the computation itself. Another amazing property is zero knowledge, where sort of the proof that attests to the correctness of computation actually hides all sort of all information about sort of intermediate states of the computation. This area is a mix of beautiful theory and applied work. There's also strong industrial interest because cryptographic proofs are becoming really an essential tool for privacy and scalability in peer-to-peer systems. There's in fact actually already standardization efforts to take some of these proof systems and sort of make them sort of standard tools and a toolkit of cryptography in the real world. And actually I wanted to mention that there's actually an event happening in 6 weeks at the Berkeley Marina. And there's a website for that here.
And also the ZK Day.
Oh, and on April 13th, we'll hold a ZK Day. We'll have an entire, we'll have several talks discuss zero knowledge proofs, applications of intersections of machine learning and privacy, and
also Algorand.
Also Algorand, yeah. So there's a lot of exciting things happening like in this area, even beyond the upcoming semester. So anyways, so one of the workshops at the semester will be dedicated precisely to this pillar. It will be the first workshop towards the end of September. So that's just one theme. Maybe let me tell you about another theme. I'll just jump to the third one. So money is an example of an important societal function. When you think about the centralized implementation, is sort of fiat money, where sort of some sort of trusted party says, here I'm issuing tokens, please, trust, I'm going to use my sort of authority to say that they're legal tender. And decentralized implementation, you can think about it, are cryptocurrencies. Now, there's some sort of new application stack that is developing where, through distributed ledgers that are enabled by cryptographic proofs and consensus algorithms, you can actually build distributed applications on top of it, for example, payment systems. Okay? But you can also ask, what societal functions are technically feasible to achieve via decentralized systems and which ones are socially desirable. And over the past few years, there's been a lot of work trying to explore how to achieve other societal functions such as elections, or maybe provide more secure supply chains that use many of these tools. Okay, this is really like, so hardcore theory applied for sort of realizing useful peer-to-peer systems. But because these applications are ultimately meant to be used and actually are being used by sort of people in society, then you run into like pretty thorny sort of questions at the intersection of economics, sort of law and ethics. So we'll actually have an entire, so the last workshop of this program will be dedicated towards exploring these applications and also sort of study questions that sort of go outside of computer science. We're very outward looking. Okay, so it's just a short snippet. There is, like all the other upcoming programs, you can learn more information about it on the website of the Simons Institute. You can see the visitors that are coming. You can read more about each of the workshops. And yeah, so it will be held this upcoming fall. So I can answer any questions.